So now in this video, basically we want to light a couple of green LEDs here, but we're only working with 5 volts. And green LEDs, they need about 6 volts absolute minimum basically to really light up. So we got a little bit of light there. They would be doing better without these 2 diodes here, but we need these to basically double the supply voltage. So 10 volts, but we're going to lose about 0.6 volts plus another 0.6 volts. So about 1.5 volts from the absolute maximum that we would be able to get out of here. So this is a simple version of a voltage doubler. But there you can see when I press the button, you get like a pulse when you press the button right there. And I kind of lost connection. If I like really wiggle this, I can get like real brief connections right there. That's all we need. Just a quick press release. If you do this really quick, then if you did it fast enough, you would get a steady glow right there. Pretty steady. It went very much because we have this 1000 microfarad capacitor that we are charging. We don't absolutely need this, but then all we're going to get is brief pulses right there. And so this helps store the charge for the LEDs. Hopefully that makes sense. The other capacitor is the one that we charge it and then pump. That does not want to go back there. We charge the other one and then we give it extra charge in addition to that. So I'll explain how that works. So now let's talk about what happens first thing when you wire it up. And this is just gray because my printer wasn't doing so good the day that I printed out this sheet. This is an old sheet. So the last couple of videos, they've been gray like that. It's supposed to be black. But in any case, we have plus 5 volts there, the diode, so current can go that way. We can have positive come this way and charge the capacitor through a 220 ohm resistor. It's going to charge pretty quickly right there. In any case, current can move a lot faster over here than it can over there. So that is the first step. Now also, when it does that, right when you wire it, we also have this diode here so that this capacitor can charge up. And so it's going to be about 0.6 volts plus 0.6 volts, so about 1.2 volts or less than 5 volts. So about 3.8 volts it will charge up to. And also a little current will trickle through the load here, but hardly any, as we saw before. Now, we come to when we press the switch. So this is already charged to like 4.4 volts. When I close the switch, if this diode wasn't here, we would have a short circuit. It would just instantly discharge. So we can't have that. So that's what this diode does. Prevent current from going that way. When we close the switch now, we got 5 volts there, 0 volts there, plus 4.4 volts here. So that is 9.4 volts approximately that is being pushed in this direction. So of course this built up some voltage too, but this is going to pump it so it raises that voltage closer to the 9.4 volts. Also, as the voltage goes up here, more current's going to go through the load right there, which is going to pull it down. So that's why there's not just one press release and then we got magically almost twice the supply voltage. We have to keep hitting that button over and over again to keep pumping charge into that one. When we release it, also we want enough time for that capacitor to charge fully for the most part. If you go quick enough, this should charge and pump current into that one faster than the current that this load needs. Voltage doublers are usually used, or voltage multipliers. You can keep adding to this system to multiply the voltage. You keep getting more drops though, remember that, due to more diodes. But yeah, you can keep doing that until you get a voltage high as you want, but the current is low. So usually if you need a higher voltage, you use a boost converter. And before we move on, this would be more effective if we didn't have this resistor to ground. But when we close the switch, there you can see we got the positive spot. So if we had a direct connection to ground, that would be a short circuit between those 2 points. When you use an integrated circuit, it doesn't connect to 5 volts as good in most cases, but it connects to ground pretty good. And so then you wouldn't have a resistor going to ground. You could just use the ground of the output, because it is either 5 volts or ground. But in this particular circuit, we always have a connection to ground, you know, no matter how we press the button there. There's always a connection to ground. So we have to limit current for when we press this. This is a big waste of current though. Another reason why you just hit the button briefly. So that will, you know, there's really no resistance this way. And there's a little bit of opposition to current flow. But you know, practically no resistance. So it's like a short circuit almost, you know, briefly right there. But it's also wasting current here. So you can just do your quick press, you'll get your pump, and by the time you release it, it's probably as pumped as it's going to get. Otherwise, you're just wasting current. So now we come to the physical board, and I'm actually going to turn the power off right now, because I'll probably, you know, short something with this sooner or later. So positive supply there. We got the band right there, the cathode. This is the 1N4001. These they both came from different kits, so they have different length leads. Might be hard to kind of tell there, but yeah, that's way down there. I had kind of a hard time touching that due to the distance. But in any case, same components but different length leads. But in any case, no gray band there. There's the gray band there. That's the cathode. Has to be more negative for conduction. So we come to the capacitor, and as I said before, these three are all in the same row there. We have a 220 ohm resistor going to the negative supply. And I just put the switch down here because it's easier to see than if I like stuck it up there, because these are big components, especially these capacitors right there. So that's coming from the positive supply up there. I could put the jumper down here to the positive supply, the jumper cable, and to put the jumper wire up there. But I like to work positive down to negative as much as possible. And then that comes up to the negative side of the 1000 microfarad capacitor right there. So the larger the value capacitor right here, the more current we can pump with each press of the button. And we have also a 1000 microfarad capacitor here. The more you pump into it, the more charge it will store, and the longer it will take for it to trickle down right there. So you get like a smoother process with larger value capacitors, but these are plenty fine right here. So we looked at that process. We press the button, and that brings positive over to a already charged capacitor. So when you got a voltage source and another voltage source in series, their voltages add up. But as current goes through this one, its voltage is going to go down, and ultimately it's going to go down until it's about 0.6 volts higher than this one right there. And you know, if you keep pumping it quick enough, this one will rise, that one will go down less until they meet a happy medium. Well, you keep pressing this because the load's going to keep drawing current. So let's come over to there. So we have the long lead again, or no, not the long lead. I'm thinking of LEDs. That's what I'm used to talking about. The anode is up there. The cathode down here, the gray band coming to the capacitor. So that prevents it from, you know, discharging back that way. And so it pumps the charge in there. And also we got the 1000 ohm resistor. Now we got the long lead, the anode of the LED right there. That has to be towards the more positive side. Short lead, the cathode, towards the more negative side. There should also be a little shaved part of the rim right there for the cathode, going to the negative supply right there. But yeah, hopefully that all makes sense. You can see that going to the negative supply jumper. I am going to turn the power back on, and we'll look. So we got 5 volts at the supply right there, and it might say CC on there when I'm pressing the button. There you can see CC. So that meant we hit kind of we needed a brief period of more than 50 milliamps of current, but that's kind of rare. So we're probably okay without that. It's not working as perfectly as it could, but probably no real noticeable difference. We can take a 470 microfarad. I would put a 1000 microfarad on there, but I think I got to scrounge up one. Usually I just have these two. Yeah, that doesn't even really seem to be helping right there with the brief currents. And okay, now it might be. So it looks like it's helping, but probably makes practically no difference. Probably slightly better though. But yeah, once we get a steady state, then current's going to be pretty steady. And also, the quicker I press the button and release it, the better that will be. So a digital circuit could give an extremely brief pulse of positive, and then stop giving that pulse much more rapidly than what I can press the button. But this is just a demonstration. With the button, it's easier to visualize what's happening than when you have digital circuitry. You can actually see me pressing the button. You know that's making a direct connection to the positive supply. It's a little harder to tell that with the integrated circuit, that all you see is a pin. You know, you don't see any movement or anything. So again, mostly a visual demonstration. You know, you can actually charge something up to a higher voltage if you really want to this way. You know, if you don't mind pressing the button a whole bunch of times. Buttons wear out though. Integrated circuit outputs generally don't ever wear out for the most part, as long as you don't abuse them, you know, put more power through them than they can handle. But in case, again, kind of a simple circuit. I kind of assume you're still pretty beginning in electronics when you come across this circuit for the first time. And so I explained more than I normally do. So long video, but hopefully you still enjoyed. Thanks for watching. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help out a lot. I'll see ya in the next video.